Well, hello everyone, and welcome to the September 2022 edition of the St. Louis Java Users Group. So for those who don't know, the St. Louis Java Users Group is an informal group. Attendance is free. We don't have a formal membership list. Normally, our meeting date is on the second Thursday of every month except December, when there is no meeting. There's just too many things going on over the holidays for us to organize a meeting in December. When we meet in person, you can join us for food and social at 6 p.m. and the presentation starts at 6:30. And when we meet in person, our normal meeting location is in the Object Computing Incorporated training room at 12,140 Woodcrest Executive Drive, Suite 310, and that's in St. Louis, Missouri. I'd like to thank the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Alsfall, that's me in the middle, Weiqi Gao, and Kathy Zwang. You can reach all of us on the steering committee if you just send an email to that address there that's at the bottom of your screen. That's javasigsc@ociweb.com. The St. Louis Java Users Group would not be possible without the support of our sponsors. So from left to right, top to bottom, I'd like to thank Object Computing Incorporated. They are our original sponsor going back to 1997. JFrog has been great because they pay the fees to cover the cost of the Meetup group and the Zoom account. It's free for you to use the Zoom and to RSVP for a meeting on Meetup, but it does cost the Jug a little bit of money to be able to have a page on the Meetup site, and they cover that cost. They also do door prizes on occasion, and I think we may have some next time. Signature Consultants and Adaptive Solutions Group are headhunters, and if you're looking for a Java position, or if you have a Java position that you would like to fill, just look them up on the web and let them know that you found out about them through the St. Louis Java Users Group. When we meet in person, they normally sponsor food, but we haven't figured out a way to send the food over the internet. So until we get a solution for that, we won't be able to do that. JetBrains, at the end of this presentation, we will be raffling 2 JetBrains licenses for any JetBrains desktop product of your choice. If you're watching the recording, I'm sorry, you do have to be present to win in order to do that, but we'll be doing that at the end of this presentation. So we'll have 2 JetBrains licenses to raffle. Elastic is the company behind Elasticsearch, and they sponsor gift cards for us. Intertech is a training company, and they sponsor coffee cups and mouse pads and the famous screaming flying monkeys. So if you're looking to improve your Java skills or your software skills in general, take a look at the Intertech website, and they've got a lot of good training classes there for you. At the end of this presentation, we will also be raffling 2 Manning ebooks of your choice. And again, you must be present to win on those. And Pearson is a publisher of lots of computer-related textbooks and titles, and they sponsor physical books as well. So thank you to all of our sponsors. As far as announcements go, the big conference, Java 1, is back after a long hiatus, and it'll be, I believe, in person. That's October 17th through the 20th in Las Vegas, Nevada. And if you want more details about that, you can get to it on that website there at oracle.com/cloudworld/Java1. One of the things we also do is we work with the sponsor of the No Fluff, Just Stuff conference tours, and he puts on lots of conferences all over the United States. He's got one coming up here in December, the ArchConf, from the 12th through the 15th in Clearwater, Florida. You can get the details about that at their website, archconf.com. And the reason I bring that up is we have a discount code for $250 off on that conference. If you just use that discount code when you sign up, that's JUG250ARCH. And so we encourage people, if you're interested, visit the website, and we got a discount code for you. Now, closer to home as far as conferences and closer in time, Strange Loop is coming up this month, September 22nd through the 24th at Union Station in St. Louis. That's an in-person event. If you want details about that, that's thestrangeloop.com. JConf 2022 is taking place later this month also, and that's September 26th through the 28th. That's in person. And right there is the link to get the details on that. That's 2022.jconf.dev. And we also have a JUG member discount. So if you want to write that down, you might want to use that discount code because you can get in cheaper at JConf. So what I might do is later on, I'll post that discount code in chat later on for those who are here. So those are our announcements as far as upcoming conferences. On October 13th, we've got our next meeting, and that will be on buried and technical debt, how to make the right investments in your code, by Chris Stone of After School Headquarters. Chris gave a great presentation on that, and I got a chance to see it at the Dev Nexus conference in Atlanta, and that was a pretty good presentation. So we'll schedule him to give that next month. So if you want to keep up with our presentation schedule, it's easy to do. Just go to our meetup page. That's meetup.com/gatewayjug for updates to our presentation schedule and location. And as soon as we schedule a presentation, you can go ahead and RSVP for it. So that's okay. And if you would like to give a presentation, or if you would like to become a JUG sponsor, you can reach all of us on the steering committee, again, at that same email address that I mentioned before. That's javasigsc@ociweb.com. So for tonight's presentation, we have purely functional programming for the JVM. And I'm going to mess up that pronunciation. By Professor Koenig at the University. I'm sorry, I don't speak Swiss, and I'm not even sure, is it German you speak normally? But your English sounds pretty good. So it sounds like your English is better than my German or Swiss or whatever, or French or whatever you normally speak. So I'm going to turn it over to you. So what I'm going to do is I'm going to click stop sharing at this point so that you can share your screen and take it away.
Yes, thank you very much.
And you're sharing your screen and it looks just fine.
Very good. Let me see whether I can actually see the chat as well. Let's try. There we go. Might be expensive to send food over the internet.
Yeah.
There we go. So thank you very much for having me. I'm honored to be on your program, and please feel free to ask questions whenever questions arise, and we will also have options for opportunities for asking questions and possibly giving answers at the very end if you prefer to do this. I'm Dirk Koenig, currently working as professor for computer science, but I have a long tradition as a Java programmer in the trenches for over 30 years. So I'm not that kind of academic professor. I'm more a professor for setting the next generation up for more success than I had. So, and telling them where all the difficult pieces are and what to avoid and what to do and what to avoid in programming. That's my current take. Actually, I'm one of the main reasons for going into this professorship was a talk by Ray Sunday, the COO from Oracle, who gave a presentation for the Swiss members of the Java user community at Java 1 in 2012, I guess it was. There's always the Swiss breakfast, and he gave a short presentation. And he said, he was talking about his current job, and he said the first half of your career is about success, and the second half is about but how did he mention it? He said it's whether it makes any sense. Well, the second half is being about the points that you make and the effects that you leave behind, right? So I was thinking about what I would leave behind, and I would rather want to leave behind not so much software, but new ideas in young people's minds. So that's why I took this opportunity there. I'm also still working at Karakun, which is a commercial company, and people might see a little of this. You can reach me on Twitter under my war name, Mitty. Okay, that's it there. So for today, that's me, a little younger. Today we're going to talk about functional programming and the Frege programming language. But first, I'd like to have maybe in the chat a short poll, just to address you correctly in terms of how much of functional programming in the Haskellish style you have already seen, how you would judge your own experience in that regard. So if I open the chat, let's say from 0 to 5, how much experience do you have in functional programming? That's FP. Let me see. There's already a 4, a 1, 5. Rebecca is a 5, of course. 1, 1, 1, 1, 1, 1, 2. Okay. 2.5 in the middle. So it spans the whole spectrum. Okay. Very good. So and now I have it from Braithwaite. The first half of your career is about success. The second half is about relevance. This is what he said. So now the word came to me. Is 5 a lot or little of functional programming? 5 would be a lot. So 5 stars. Okay. Here we go. So we're talking about Frege. Frege is just like Dirk, also a German name. And I understand that it's kind of difficult to pronounce if you're not German native speaker. Therefore, if you're English native speaker, you're totally allowed to call the language freaky. We make this concession, and we won't hold it against you. So Frege was a German mathematician and kind of an interesting figure, because he was the first one who coined the term of higher order functions, functions that take functions as arguments and return functions as result values and so on. And that was, of course, long before there has been any computers. So interesting, in his honor, the language was named. And there is interesting background stories about him, because he made like 3 revolutions. He started a revolution in logic, in mathematics, and in philosophy. So that's many. For starting, maybe for setting the stage about functional programming, and maybe a little bit beyond what you usually see in terms of, Java Streams API and map filter reduce and higher order functions and so on, which is kind of now mainstream Java knowledge. And I assume you're all well versed in Java, in the Java user group. There's a different way of thinking about functional programming, and I'd like to start it like so. We're going to dream of some code. And this is, maybe go back. That was a short glimpse, and I reveal it in a second again. So it's 5 lines of code, simple assignments. We have like 3 variables, A, B, C, and we think about what they are doing. So I try to read the code to you, and you might want to close your eyes and figure out what the code is doing. Clear so far? So 5 lines of code, I'm going to read the code, and I close my eyes as well. So A equals 1. B equals 2. Everybody still with me? Fine. C equals B. B equals A. A equals C. Clear so far? Anybody, any guesses what the code is doing? What the purpose of that code could be? Shall I do it again? Give me some nods. Shall I do it again? I'll do it again. Give me a second. So now that you know what's awaiting you, it might be easier to follow. So swap 2 values, 10, exactly. Thank you. So here's the code. A equals 1, B equals 2, C equals B. So it's an assignment that we give to, in the first week of learning to program, you have this kind of assignments, right? And you learn typical imperative programming. That's imperative programming. And when reading the code and understanding what it's doing, it's quite a lot of code for only swapping 2 values. And figuring out what actually happens seems to be more complicated than it should be. Why is it more complicated than it should be? Because in your head, you have to do the following. When you read the first line, you make yourself like place in your head where you put an A of value 1. So you have to put this, you have to commit this to memory. Okay. And then on the second line, you have to remember 2 values, A equals 1, B equals 2. Okay. And then third, A and B stays the same, but then there's a new value, and the value from B gets into the slot of C. Okay. So, and when B gets a new value, the value of A and C stays the same. But B gets the value from A, okay, that goes over here. And then lastly, B and C stays the same, but A gets the value of C. Now, why is that even a little bit involved, a little bit complicated? That's the kind of thinking that we as programmers are so used to. Actually, we are a self-selected group here. People that don't like this kind of thinking, they don't go into programming. They don't come to the Java user group, right? So it's actually us who are the experts in this kind of thinking. And still, it's not as simple as it could be. It's somewhat involved. And why is that? That is because not only do we have 3 different places that we have to care about, place A, B, C. We have to care about these places at 3 different points in time. At the very beginning, it's only an assignment, but then a little later, things have changed. These places are not stable; they're changing their values, and then you have to refresh your memory and keep track of at what point in time which place had which value. Which means in total, you don't only have like 3 places that you have to care about, but you have like 9 different states that you have to keep in your mind. And the most short-term, the most people have a short-term memory of 7 plus minus 2. Mine is probably at 5, so I'm pretty bad at memorizing this stuff. But I'm pretty good as a programmer anyway. So that's the idea. And not only is it 9, there's even a question. What is, for example, at time 2, time 1 makes sense, 1, 2, 2. Time 3 makes sense because you see the swap values. But in between, you see an inconsistent value. You see A and B is 1 and 1, and that makes no sense at all. You know, we somehow have to program in a way that the intermediate state never gets out. We have to care about this. Okay. But still, as long as we program this way, we are still in a problematic situation because somebody from the outside may read the value A at time 1 and the value B at time 3, and also gets an inconsistent state, right? He also sees 1, 1. This is not nice. And the whole situation comes because we have a destructive update, that's called. So we are overriding a value in this place, right? We are overriding the value of B. We are overriding the value of A. That's a disruptive update. Destructive update, so that's the right word. Destructive updates are not nice. You know, they're difficult to get your head around. And then most of the time, when we make errors, in order to find out where the error is, we need a debugger. Because the destructive updates is where bugs hide. And then we need a debugger and single stepping, and we go through the IDE and look at the values at different times and try to figure out where the bug is. Right? That's the main reason why I use a debugger, is single stepping and see at which point in time, which place, at which value. It's one of the main reasons for bugs, and therefore you need this kind of special debugger. Okay. At one point, I was explaining these difficulties to my parents who wanted to know what I do for a living. I was explaining this kind of thing, like 2 things stacked on top of each other, you want to turn them around and so on. You need a different place where you store it, an intermediate state, and so on. They kind of figured it out. Like 2 things beneath each other, and you want to swap them, you need a different place where you can then swap over and so on. I was explaining this with a coffee cup and a saucer and so on. And then I said, you know, that's the old world. The new world is as follows. We want to get rid of this problem, of this destructive update. We don't want to have this. We're taking the coffee cup and the saucer, and then we don't change it. We call this immutable values. We no longer change that. Case closed. And then my father said, yeah, well, boy, at this point, they kind of found out why I'm so crazy, you know. So he said, well, you know what? You wanted to see the values swapped over, right? And I said, exactly. I want to see them swapped over. I don't want to swap them. I want to see them swapped over. So I took my classes and I said, well, just think these classes are special classes where with this prism, where I see the left-hand side through the right glass and the right-hand side through the left glass. I put them on and I see it swapped over. I don't change it in place. I only see it swapped over. Everything stays the same. Right? That's the idea of working with immutable values and functions. These classes, functions are just classes, right? And there's so many different classes that I can use. I can use classes that give me only one value, the first value or the second value. I can have classes that times 2, I see everything bigger, right? And so on. So it's multiple classes. I can even put multiple classes on top of each other and then squash them together to see the combined effect of all the classes. We call this function composition, right? That's my take of functional programming. And then the swap function is kind of easier to understand as the imperative function there, imperative procedure that we had in the beginning. So that's kind of the setting the stage for what we're doing. Now, this applies, these rules apply even to plain Java. You don't need Frege or Haskell or so for this. It's a plain Java thing. So we can do this in Java. So let's try, you know. We're just working with immutable values, and functions in Java would be methods in Java, but we can make static methods and they work as functions. And we no longer do assignments. And assignment is a special kind of statement. So if you don't have assignments in your language, you're not using assignments for destructive updates, you don't need statements anymore because everything is an expression. Okay. And here's 2 ways in which you can do this. The blue pill and the red pill. The blue pill is everything stays the same as you know it. And you rely on developer discipline to no longer do statements and control structures and while and for loops and so on. But you're only using expressions. Discipline is one way of trying to get it running, right? But also developer discipline falls apart sooner than later. It's also a truth. And the second way is you're using a language, and here comes pure in the mix, a purely functional language that only is constructed out of expressions and has no statements. There are no statements in a purely functional language, only expressions. So no longer do you have like println A, semicolon, println B, semicolon, and so on. Statements, statements, statements. If you have statements, blocks of statements, then you need control structures to have your thread of control running through the statements and looping and branching and so on. But if you have expressions, you don't have this. Right? There's an expression, done. You don't need control structures. And this is what a purely functional language has. It doesn't even give you the means of opting out of the functional world. That's what the pure means. And for this talk, we are delving into, we are taking the red pill. We are like Neo from the Matrix. We are taking the red pill in and jump in head first. That's the idea. We are going strong. Now, with this approach of only having expressions and no statements, we can actually impose new rules in the type system. We all have the Java type system, which allows us to have really good IDE support, you know, code completion and so on. It's all based on the type system in Java. It shields us from silly errors like mistyping a method name and so on. It allows some runtime efficiency, like an integer and a float and so on that are distinguished, and it can be more efficient. The constructed code can be more efficient. Right? It allows a certain type, the Java type system allows a certain type of refactoring. But actually, if you're looking into the details, most of the refactorings that we know and love in our IDEs are not totally safe. So from a computer science perspective, they are not safe at all, because there's all kinds of possible trickiness, especially concerning side effects and sequence of side effects, that can be changed through a refactoring, and then you still have to apply your knowledge as an engineer. You cannot totally rely on the tool. With this new approach, we can actually not only be shielded from silly errors, like mistyping a method name, we can actually find tricky errors. Here's one. I talked with Bruce about JavaFX, for example. In JavaFX, there's a rule. The rule is if you touch any of the UI elements, a button, a text field, whatever, you must be in the JavaFX UI application thread. If you're not in this thread, you get no guarantees whether you see the right value or whether your updates will be displayed. That's a rule. Now, what possible means do you have in the Java programming language to kind of find out through the compiler that you're in the wrong thread? You have absolutely no chance of finding out through the type system. But as we will see a little later in the talk, Frege can actually do this, because there's Frege FX, Frege language binding for JavaFX, and it ensures in the type system, you will see this, that you can only touch UI elements if you're in the correct thread. And if you want to do any other side effects, that's the reading from a URL, going through the database, do something on the file system and so on. If you want to do this, you can only do it outside the JavaFX application thread. That's kind of the best practice. It's not really enforced, but something that you should do as a programmer, as a UI programmer, because there's a possibility of let's say IO exceptions coming up. And if you're in the UI thread, when an exception is not caught and handled correctly, then the UI freezes, right? Goes up the application thread, and you cannot even react with an error message anymore because the UI is dead. So those are tricky errors that you can very easily do as a programmer. And with a language that is based on expressions only, we can guarantee that certain tricky errors can no longer occur. That's the idea. Then these kind of types that we now have with these languages, they have a different way of communicating what the code is doing. You can also use them as a design tool. You can use this to find new ways of extractions, and also gaining more insight what the code is doing. We will see this in a second. Those are labels, and the slides are labeled according to these various strong guarantees that we get. And all this is based on the purity. It's based on the purity that we have pure functions and only expressions and immutable values. That's what we get. We will later see we have to pay a price for that, as you might guess. But if we have this, if we have the purity, then we get this. So let's see. What does it mean to be pure? Pure functions produce the same result giving the same arguments. So anytime you're calling a function with the same arguments, you always get the same result. That means, for example, if you have a function that has no arguments, it always gives you the same result as well. So it's practically a constant function. So constants are like functions of zero arguments. And there are no observable side effects. That's a pure function. I guess that's probably common knowledge, but I wanted to repeat it. once you have these pure functions, you can cache them, right? For example, let's first go through the list. You can evaluate the function lazily. You know, I'm going to need the 31st prime number, but it's not quite, I only need it later. So I can defer, since the 31st prime number will always be the same prime number. It will not change. It's an immutable value. I can calculate it later in case that I actually need it. Or I can actually evaluate this in advance, because I know even before the program even runs, I can make a table of all my prime numbers and then look up in the table, because it doesn't depend on the time when I calculate it. I can evaluate this concurrently. I can evaluate all the prime numbers concurrently, and no prime number affects another prime number. It's all pure. So it gives me tangible benefits if I know whether something is pure. Also, if I have an expression, like more complicated expression, at one place, in the second place, in the third place, in the fourth place, I can remove all these places and put a number in, put the result in. I know that I can do this because it doesn't depend on the circumstances when I calculate it. And this is a lot of optimization. Here's an example. You can write in the chat, what is the cosine of 0? Like, let's say, I put this in, cosine of 0. There you go. One person, Ted, of course. Here's a new one. Everybody in the chat, what is this value, cosine of 0? Usually the answer comes quicker. And the answer comes quicker because you just heard it, the result, and you know that the result doesn't change between the first and the second question. You know, you cached the value. And that's you implicitly knew that the evaluation of the cosine function does not depend on the time of day or who answers it or anything else in the surrounding. It's a pure function. So knowing that an expression is pure, that a function is pure, pays tremendous benefits, can be highly optimized. It's easier to understand. You can make a table lookup, right? That's one of the easy, you can cache it. I mean, this is so easy to optimize. Now, if we're in a normal, let's say, Java-like programming language, do we know whether a function is pure? We see a function, a look at the type signature. Do we know whether it's pure or not? Here's a question. So the function that's from a profiler, the function, it's hard to read, I know, I read it for you. So at the very top, it says, org hibernate EJB configuration add classes to session factory map. Okay, it's one of those things. You don't know, you have no idea whether it's pure, so you have to look into the code. And the first line of the code in this function, in this method, calls configure properties map. So I look into configure, and in configure it says, so the persistence unit info must be called. Oh, okay. And then you go down the whole call stack, and this is a real life call stack here. So practically, you have no chance of finding out whether anything down below in the call stack might produce a silly side effect. You have no chance of finding out. And even if you put in the effort of reading all the code, any change to the code base somewhere might compromise your knowledge. You actually have no idea. But we have tools that can find out the type system. You can use the type system to find out whether a function is pure or not in a Haskellish language. So, here it is. And we're going to talk about this a little bit more. Our pure types that we have. I've already mentioned this. In Java FX, these constraints, transactions, if you have software transactions, you're not allowed to do side effects in a transaction because you might want to roll back and then you cannot roll back side effects and so on. But also, let's say in a Java stream, you should actually never modify anything in a higher order functions that you pass to map filter reduce operations and so on. If you do, and for example, limiting the stream is that kind of function, then you get very erroneous behavior. I've later a small example about surprisingly erroneous behavior in Java streams. So that's the point. It's about correctness, safety, reliability of your code. So less tricky errors. One is runtime efficiency with our kind of types that we now have, less tricky errors. Maybe because that is currently in a piece of code. Let me show you this in an IDE. I'm not quite sure whether this is readable. Let me quickly check whether I can make this a little bigger. Can I make this a little bigger? Can you read this? Can you give me some thumbs up or down? Okay, good. So the idea is, let's say, we do have a main function. I removed the type just for the fun of it. I'm removing some types, and okay, good. What we're going to do is we have some messy input that is somehow dependent on the world. For example, messy input is a function of no arguments that reads from the system the current time release, so the current time. And then we do some calculation. For example, we divide, so here, we have some pure calculation with our milliseconds. And that is, we are dividing by 1000 because it's easier to understand, to read it as seconds and not as milliseconds, let's say. That's a pure calculation. And then we're doing some println, which has a side effect, of course, because we're going to see it in the terminal. If we run the code down below here, it's going to appear right below. There comes your value. There you are. So we have like 3 different things. One is a messy input. Now the system, because we rely on expressions only and not on statements, the system can actually find out that current time release is not a pure value. It's a value that only comes through the I/O system, input-output system. And therefore, if I hover here in VS Code over the function, over the method, I see that that's a Java method. And from a Frege perspective, it does not give back a long, it gives back an I/O long, meaning it is an action that when performed returns a long value. It's a messy thing. Yeah. And The output prints to the output system. So it takes a value that hasn't, it's called show type class. So at this point, that's like, it has a toString, let's say. And so I can actually make it to a string by using the show function. Show x makes a string. Show takes something that is showable, that would be the Java term, and of this object, it makes a string. So it's a stringable thing. So there's messy input and messy output. The calculation is from a long to a long, and that is pure. So the type system's way of telling me whether something is pure or not is by having this special kind of types that looks like two types, like IO looks like a type and long looks like a type. Yeah. It's kind of the context in which the type lives. There was a question? Okay. So that's the way of the type system telling me this. And note, I have not given any types here. I did not kind of claim that it is pure. I did not claim that this is pure. I did not claim that this is impure. It's all automatically calculated from the contents of the function, from the implementation. So I cannot possibly fool it if I try to fool it. So let's say messy. I can give the messy input. I can give the correct. This is the way of typing this. So is a function that returns an IO long. Okay, and that works all fine. Meaning it's a long that lives in this IO context. It's messy through IO. That's the way that the type system tells this. If I would claim that this is just a long value, a pure long value, this would be a pure long value, then the type checker tells me, you told me, you tried to fool me that this would be a long, but no, because your implementation is messy. This is what the type system says here. So I have to give it IO and compile it, and then everything goes away. So that's the idea. Same with transactions. If you have software transactional memories, you're not allowed this. This, for example, is the Eclipse plugin. In the Eclipse plugin, here's the software transactional memory. This is a piece of code that is not allowed to have side effects. If you do a side effect in here, like a println, then the compiler says, you're not allowed to do side effects. Shielding me from tricky errors, less tricky errors. By the way, I have been talking about that certain side effects are not allowed. You want to have side effects with limiting at this case. I call this a random number generator, RNG, because in just a normal Java stream where you have a supplier of numbers and you want to map the numbers to the squares and then sum up the squares, that would be the stream here. If you do this and you're limiting to the first 10 numbers, right? It would be nice if I knew that all this constructed iterator that is behind the stream is actually pure and that I can just run it in parallel. But if you do it this way, as here on the slide, you get totally random numbers for the sum. And that is because the stream implementation, especially these splittifier. What's the splitterator that splits for the the iterator that splits for parallel execution, this is actually not a pure function. So it's not so common, but a possible source of errors. And the type system cannot possibly help you here. Would be nice if it could. In Frege it can. So for example, if you want to follow in the browser, there's an online REPL for a little piece of code that I'm trying to show. You can use either of these URLs. I'm gonna take the, sorry, oops, go one back and take this string here, put it in the chat that you can go there. Let's see whether we can find it in the browser. See whether that works. You should see this piece of code. In case that anybody could connect, at least one could give me some indication in the chat whether it worked. Because I'm actually running this online REPL on the university's premises. So it sits in our basement. But here's some kind of interactive read eval print loop, and we can do. Doesn't work for you? Try Frege.org. Let me see. Let me click it. See whether I. No, okay. That was Mr. Try, and I'm sorry, that was my fault. Might be a problem. Yep. Yeah, I guess I misspelled the URL there, but we can use the other one. Here we go. Or I might have, I guess I have forgotten the port number. Then we take the other one. There we go. No, was already bound. Happy in chat. Is that going? That should have worked. Over there. So, well, if not, then I jump over this. Well, usually that works, but sometimes if you want to start it twice, then you get like bind errors on the port and so on. So anyway, so I leave this for the moment and go back to the presentation. And there we go. So here a little bit of how functions look like and what is typical way of programming in this kind of languages. Those of you who have seen Haskell or PureScript or Elm or Idris or one of those languages before, that they have seen it already. So if I define a function, let's say, for example, the times function takes two arguments, A and B, and the implementation is A times B. I can now call it by giving the arguments 2 and 3. So there's no parentheses here. And result is 6. That is the idea. Now, question is, what type is times? You know, what kind of function is this? What's the function signature of times? Well, normally we as programmers have to say what the function signature is, and then the let me know if that other thing is working. Then then it's working. Now it's working. Okay, then you can follow along. Good. I guess there was some copy paste error there. Good. So what's the function, right? So there's a times in between. There's the star operator. And the star operator says, well, I only work for numerical values. You can int times int, float times float, tuple times tuple, big integer times big integer. But both sides must be the same function, must be the same type. Both operands for the operator must be of the same type, and it must be a numerical type. So if we type times, it gives us num A to A to A. So what is that? That looks kind of crazy, right? So num A means it's kind of type class in Haskell and Frege. It's pretty close to an interface, I'd say. For any numerical interface, if I have a type of that interface that implements that interface, numerical, then we have this kind of minus greater than is a function. So we have a function that takes a number and returns another function that takes the second number and then finally returns the value. That's the way that this reads. And it's kind of very regular way of writing these things. So what looks like a function of two arguments is actually a function that returns another function, waits for another argument, and then returns the value. We did not declare any types, but it was totally fully typed, from the bottom up. And we can call this without the parentheses. Parentheses are optional in this case. They are left as function application is left associative, so it is parentheses go to the left. That's the way of writing this. And this is what I said before. There's a rule of thumb that many developers like to fall into, and that is this kind of parameters that you see. It's like all parameters to the function until the last one, and the last one is the return value, return type. There you go. Once I have a function is just an expression. So an expression can have a name. I can give a name to an expression and refer to this. So I can use it like times 2. We have seen times is a function that takes an argument, 2, and returns another function that waits for the second argument. Okay, so 2 times equals times 2. Here's kind of looks like there's an argument missing. It's not really missing because times 2 is a function. Okay. If 2 times is a function, then I can call it. Of course. Okay, and it gives me 6. Now, what is the type of 2 times? What is the type of 2 times? Now, since I've given the 2 over here, this already limits the possibilities, because in the beginning, times AB equals A times B, it could be every numerical type, And now we have already fixed the type. 2, whatever 2 is. In our case, 2 is an integer. Therefore, the type of 2 times is int to int. And you get all these guarantees, right? That is nice and tidy to work with. Remember, this kind of gray X that we see here was not there in the beginning, as if it was missing. 2 times, as we wrote it initially, was a function without arguments, meaning function without arguments with constant value, a constant value of type function. Okay. But there was this X over here, right? And we were removing the X. You can put the X in which case it's somewhat kind of the same thing practically, but from a conceptual point of view, it's somewhat different, because here I say the 2 times function is the function that for every data point X, I calculate this as 2 times this X. Whereas if I don't give the X over here and the X over there, I'm kind of giving it for all values at once. For all values at once, here's the function that doubles any values. And since this is for every data point, and the other is for all data points at once, the first way of writing it's called is the dot-free notation. Anyway, when I have functions, I can combine functions. For example, in our 2 times, I could have 3 times of the same thing. It's 3 times AB is, so 3 times is times 3. I can do this as well and then have evaluation. So 6 times X would be 2 times 3 times combined. Okay. But I can write this as the combination, that's the combination operator here. 2 times combined with 3 times and give the X. And now we again see the X at the very end and the X at the very end of the left-hand side and right-hand side, both at the very end, and I can actually remove it. So I have the point-free notation. As I said, dot-free notation, that's not right. The point-free notation, not for every data point, but for all those at once. So I can write a new function, a more complex function from smaller functions, bigger pieces of code from smaller pieces of code. The 6 times function as a combination of 2 times and 3 times. So that's the kind of reasoning and way of writing code in this language. So I can call this, I can apply number 2 and I get 12. 6 times 2 is 12. That's kind of the idea of how to write the code here. This is a function that takes as an argument an expression that is another function and an argument, f of g of x. This is the f composed g. And then I can f composed g apply to x and just the composition. That's kind of the mathematical notation here. I can actually remember the times when my math teacher was explaining this in the math class, and I was thinking, so how useless is that? And now I make a living out of this. Yeah, it's true. I jump over pattern matching and so on. That's more like a lot of interesting and crazy things that you can do with a language. It's a different kind of programming, very interesting and nice way of programming, but I'm jumping over this for the sake of time at the moment. reduced to the max. So I can apply, I can give the special types, but I can also rely on type inference of the compiler. But I can also, if we go back to our code, VS Code, where were we? Yeah. Here, for example, pure calculation, it's from long to long because 1000L, the L is a long. If I have it without the long, that's still from long to long. Sorry, I have to compile this. Now it would be from int to int. I could make it from number to number if I wanted to. But here, it's already special. If I would claim that this works for any number, if I would claim as a developer that it is more general than it actually is from the implementation, then this happens. So I could try to say pure calculation is of type for all numerical values A. It is from A to A. That's what I could claim. But then, sorry, it was in the other language. So, but now, compiler says, you claim that this works for any numerical values, right? But I say it must be at least an integral value because the diff operator is only working for integral values with this int and integer and big integer and so on. So I cannot possibly claim as a programmer that things are more general than they are by the implementation. The implementation still can be more general than what I limit my function to. And then the limit will be used on the call side. So I have really the best possible type support in these languages. And then now I get an error over here for the millis because long and int don't fit together. Because from pure calculation, millis needs an int, but millis over here, after being applied, after the action being executed, this is what this error means, execute this action and use the return value. But this is a long and integer don't fit together for the diff operator. Therefore, this must be a long value. So you might say, a bit more work to do to get it right and make the compiler happy. Yeah. But then if the compiler is happy, chances that you ruled out a large amount of possible errors that will bite you later is actually the case. Now we have like different constraints that we care about. For example, the supplier, the designer, the implementer of a library, of a function, cares about parameter constraints. So the parameters that come in, the arguments that I calculate with, they must fulfill certain properties that are such that I can work with them. Must not be null and so on. Whereas the consumer cares about the result constraints. I call a function, I know for a fact about these constraints. One interesting constraint in Haskell-ish languages, especially Frege as well, there is never a null. There is no null values in Frege. So never, ever have I gotten a null pointer exception from Frege code. That is, you don't get any null pointer exceptions anymore. If you want to know more about this special way of writing code and and lots of considerations. There's a very good talk that you will find on YouTube from Runa Bjarnason, Liberties Constrain, Constraints Liberate. So if you have constraints, for example, for your parameters, that liberates you when you're working with them, because you don't have to check all the time for all possible craziness. Never, never, never will it happen in a Frege function that the argument that you get is a null. There is no null. You will never get a null. There is no way of getting a null. That's it. It's a constraint that you know it's never null, but that liberates you when working with it. You don't have to check for it. It's a practical thing. It's a thing about less tricky errors, but it's also a communication thing. Yeah, your functions. I jump over this. We had enough of this. Now comes an interesting and very important point for any language on the JVM. I have quite a long tradition of working on the JVM with different languages. And the most important point is how you integrate with Java. With Java, the programming language, but even more the Java platform, the JVM, the Java libraries, the Java ecosystem, and the way of thinking that the Java programmer has. Therefore, there must be a really good story on how to integrate your function with everything that is already on the Java platform, in the Java ecosystem, all the libraries that you have in Java. And if you're working in an enterprise environment, I bet your enterprise has its own frameworks and libraries and best practices and so on that you also have to integrate with. The approach of Java interoperability in Frege is do not mix freely, but have a very clear demarcation line. You can combine them. So here is your Java code, here is your Frege code, and they can talk to each other, but they cannot be totally mixed like you have, like, for example, in Scala or so, in these languages, where you just willy-nilly mix these languages, because as soon as you mix, you lose all the benefits. Combination is fine, mixing is not fine. So it's combined, not mixed. It's a new James Bond 007 ordering of your martini. So first story, how to call, if you're in Java, how to call Frege code. Frege compiles Haskell-ish looking code to Java source code. We're actually producing Java source code. And you can look at the Java source code. For example, if we're in here is the REPL. Let's do something in the REPL, for example, println hi. Execute it. It gives us a hi. And from the last evaluation, I can see the respective Java code that has been generated. So I say Java. And here you see the Java code. It was actually calling println through a special way of holding onto this. And then there's meta information about it that Frege has to keep track on. Therefore, the other strings, the other stuff here, the type information, and the hi. You might notice all the surrounding scaffolding that we need is final and static. Meaning, this is very, very friendly to just-in-time compilation, to hotspot, and so on. So it actually gets optimized like crazy. If you have, we do a very good performance that you, in many cases, performance, if you write like your normal Java, normal instances, and you're not optimizing your code with static and final and have all the memory models in mind and so on. If you write beginner Java, then your Frege code will actually mostly be faster. That is one point. It's generating Java code, and from the Java source code, we have the bytecode. You can just call it. It's a normal function call. And here we use Java in the command line REPL, in the command REPL. Second way is different, because now if we are in Frege and we are using Java methods, like for example, a system current time release, at some point we have to say what, from a Frege perspective, the proper type of system current time release should have been. Because on the Java side, it just says it returns a long. And at some point, we have to say, well, you know what? It's not really long. It's an IO long. And you must say this before you can actually call this function. Here, for example, that's the way of writing this native millis. So I make a new function, millis. It is implemented by Java language system current time release. And the type is, it's a function, takes no arguments, returns an IO long. So at this point, it's my responsibility to tell the Frege compiler what the Java type should really be. And we have gone through the Java standard library and did this for a large portion of the Java library and even JavaFX and so on. So we already did this for you. But for your own code, you can also do it like this. Meaning, then you get all the benefits, right? Sometimes even Java code is pure. For example, here's a function JavaNet URL encoder encode. It takes a string, returns a string, does some string replacements and so on. That's pure code. And then you can just use it like so. And also the Frege perspective on this code is pure. So you can put your knowledge and your assumption about what the type of your Java method should really be in one place. That's the idea. I go over this. So Frege allows calling Java, but never unprotected. There's also a difference to, let's say, for languages like Scala and so on. It's never unprotected. It is always explicit about possible side effects. That's a prerequisite to save concurrency and deterministic parallelism. There's a question. Hello, Leo.
Hello, can you hear me?
Yes, I hear you.
Ah, excellent. Can you go please one slide back again? Yes, the first function is pure. And why is it pure? Because you just wrote pure in front of it, or because the system somehow magically found that it's really pure?
The system cannot find whether it's pure. The system can find things that cannot possibly be pure. Even if you say it's pure, there's a certain amount of functions where we can say it cannot possibly be pure. For example, getters and setters. If you have a getter, it usually has no parameter to it. There's no argument, but it might return different values at different times. Typical getter function. So a getter function is never pure. And a setter function neither, because a setter function takes an argument, but has no return value. Meaning if on the Java side, the function has no return value, it cannot possibly be pure. So even if you try to fool the compiler will say, no. At other times, because the information, whether something is pure or not, whether something, or even don't even talk about nullables and so on, because that information is not in the Java library, in the Java functions, it's not in the code itself in a reliable way. This is why we need to have the native declarations. That's actually, this kind of approach has become very common. For example, if you're on the web, if you're using JavaScript and TypeScript, and you want to integrate JavaScript and TypeScript, then on the TypeScript side, you have to say what kind of types you suggest for the JavaScript, these all DTS files and so on. So it's kind of same approach to an extent. And can it be a possible source of errors? Yes. There's errors that the compiler detects, but there can be errors that you cannot possibly detect. It's possible. So the point is, if there is an error, if I did an error, I have one place in which I can fix it. It's actually a pretty huge benefit. Also, sometimes if I write Java code and then I use the Java code from the Frege side, and I have to say what the proper Frege type would be of that Java class, of the Java function, Java method, it makes me a better Java programmer, because this mind shift, that I have to be much clearer about what the code is really doing. That actually helps me as a programmer. Make sense so far? Good. So there we go. Overall, that's the story that we have kind of seen already in our code. We have mutable IO, messy, brownish code, like exactly what we have seen here. So main is of type IO something, messy, messy, messy. The word is messy. Everything's messy, but there is islands of purity, which we can work with. These like clean, crystal clear pieces of code that we can think about and apply algebra. And after a while, this code becomes like an algebra, and you can work like algebra with your refactorings. For the first time ever, with pure functions, you can actually have reliable refactorings, like mathematically sound refactorings. That's also new. I'll go over this. The type inference is global. So from the smallest expression, a pure number, a function call, and a function call of a function call, and so on, from the bottom up through the whole system, everything is inferred from the compiler. It's not like in languages like Java, where you, at the method border, you're giving a type signature and claiming something. So everything that you claim is actually proven. There's a proof behind it in these languages. Meaning, is actually the amount of safety that you get is so much higher. That's the main reason that when it comes to the cryptocurrencies and blockchain and so on, this is where Haskell is used most commercial, in the commercial settings, because their safety and correctness is really at stake. There's a number of things that I usually say, but I guess it's already late. So in order to find out where the language stands in the ecosystem, before I show like two more demos, it is, if you want to look into the language landscape, say there are practical languages, they're nice to work with, Java, Groovy, and so on. And then there are robust and safe languages like Haskell and Frege and so on. Then The practical languages are nice. You want to run computers and have your JavaScript and so on. And then the pure functions, the really reliable and robust ones, there you want to apply logic. And here Frege makes the Haskell spirit accessible to Java programmers, providing a much higher level of safety. And we'll look at this in the demos. I'll do the demo right away. Here we go. Practicality and safety. That's the story here. For example, let me go to the cover flow and just start the application. We'll look into this in a second, how the code looks like. I hope it contains some animations. I'm not quite sure whether Zoom is good enough that the animations will really be shown in a smooth manner. Here is I leave it like so. So there's pictures. It's vacation pictures for me. And when I click on this, there we go. Cover flow. Oh no, I put it in the. There you go. I use the arrow keys. Arrow key to the right, arrow key to the left. Is the give me a thumbs up if somebody sees the animation. Is that, or is it totally gibberish? Question. So it's cover flow. Okay, good. And then you go through it, and even if you go like crazily fast, it still works and so on. That's a small JavaFX-based application using Java, JavaFX, Java Platform, JVM, and so on. But written in Frege with the use of FregeFX. That's the code. That's just as a short introduction. That's the whole code. That's it. Here's a number of things and I already talked about, you need to be in the right thread, the JavaFX UI application thread, in order to touch any of the UI elements. And this context, what was the IO context before in JavaFX, this context is called here JFX. So you must be a JFX type. And all these JavaFX UI elements are of this JFX type. And there's only one way of entering this context of a JavaFX type, and that is by entering the right thread, which is already done through a convenience function here. Meaning, for example, building the UI, there's groups and stages and so on in JavaFX. And I return a new group, which is the main content of the UI, that is of a JavaFX type. If I'm not in this JavaFX context, let's say, let's say make a new pane. Let's say I start somewhere, for example, in the main function, which is of type IO. Let's see, which is of type, quick check, IO unit. Takes an array of strings, the arguments, and returns IO unit. So I'm general purpose IO, and I'm in the main thread. I'm not in the JavaFX UI application thread. I'm in the main thread. And if I try to create a pane, then it says, you know what? This pane is of a JavaFX type, and you are of an IO type. You know, this doesn't work. You cannot possibly even create a pane if you're not in the right, let alone touch it and change it. But you cannot even create it in the wrong thread. That's the point. Second, and it also works the other way around. That is, for example, Here I'm positioning an image view to the right place and give it the right dimensions and so on, which is something that works on an image view, and image view is in JavaFX UI element. Here, of course, we are inside the correct thread. If in this thread, I try to make a general purpose IO, writing to the console, fetching a URL, writing to the file system, going to the database, I'm not allowed to do this. No, it can harm the UI. You must go outside and do it outside and then come back. So if, for example, at this point, I'm printing position, for example, and yes, so it says, no. Yeah, you cannot possibly do IO in a JavaFX application thread. That's the idea. And then here we go again. So that is the purpose. And there are more of this kind. I guess I'm finishing up with the presentation. So there you go. So what is unique in Frege, to sum it up? Global type inference. It's not the kind of inference that you have in Java where you don't have to repeat the type signatures multiple times on the same line. And then it's called type inference. It's kind of inciting to the word type inference. Sorry for that. I'm Java champion. I'm not allowed to talk bad about Java, the programming language, but this even calling this type inference is just wrong. It is a shorthand notation that you get when there's no inference going on whatsoever. Anyways, it's muddying the waters. So inference here is, no matter how deep in the call stack of your function, if something is not of the correct context type, it is immediately visible at the very top. Almost the same as, or very similar to, if you have checked exceptions in Java, and there would be no way of catching them. Then you would get the same effect, that calling a function does something that throws an IO exception, and you cannot possibly catch it in between, and it percolates up the call chain up to the very top. Then you would get the same effect in Java. Here comes the thought of the day that you can ponder for the next week. Why does system out println in Java doesn't throw an IO exception? Okay. Now, and you might want to look it up in the Java source code. It's instructive to look it up. And turn on the annotations who committed the code. So there you go. We have purity by default. Everything's pure. If something's not pure, you have to give the exact effect that it does, like JFX, software transactional memory, IO, whatever it is. You have to be explicit about it. It's kind of, you can opt out of the purity, but then it's visible that you're opted out. And it's everybody who calls it must be also, but it automatically becomes tainted with this kind of messiness that one implementation introduced. This allows type-safe concurrency and parallelism. We have a laziness by default. I didn't talk about this. All values are immutable. There's no exceptions. And these guarantees that you have when you write Frege code, they also extend into the Java code that you're using because of the native declarations. Every single of these characteristics is unique in Frege as to my best knowledge. There's so many Java languages. There's so many languages for the Java programming system, for the Java platform, that it's difficult to give guarantees. But to my best knowledge, Frege is not only the only language that has this combination of characteristics. It's actually each single characteristic is only available in Frege. There's some small other languages in the academic area that nobody knows that have one or the other, but mainly that is true to say it this way. You get robustness under parallel execution. You get robustness under composition. That is actually huge. Robustness under making small increments. Robustness under refactorings. It enables a new kind of reasoning about your code, not only local, but also global equational reasoning. And I would say it was for me the best way to learn functional programming, the real pure, the real stuff, and still staying on the Java platform, which is the language, the platform that I know and love and work from 9 to 5, right? It's actually useful there. One can say, well, but is there anything that I cannot is there something that I can program in Frege that I cannot program in Java? No, there's not, because Frege compiles the Java source code. So everything that you do in Frege, you can do in Java. But there's a new approach of problem solving that you see here, and that is interesting to learn. How to learn? You can pick up any of the Haskell books. Here are some prominent ones from First Principles. I've heard that Bruce already has this book, and Rebecca is writing a new one. And from pretty much all popular Haskell books, there's one or the other project on GitHub that translates all the examples to Frege, which mostly means just renaming the file from .hs to .fr and no other changes, but that's for the initial content here. There's a few small changes that are kind of obvious to do. For example, strings in Frege are Java strings. Java strings are pure and immutable and so on. So that's kind of a normal thing to do, whereas the strings in Haskell are somewhat more difficult. So we made a small change there. Then there is, and that applies to pretty much all content that you find. And there's also kind of an instructional online book for Frege as well. And there is a massive open online course on edX, FP 101, where I was also part of the group, and I provided all the assignments and all the example solutions also in Frege. You can work with different languages in the MOOC, but you can do it in Frege as well. So we're kind of the community is interesting. We are like 3,500 GitHub stars. That's also quite impressive, actually. By stars, if you vote by stars, then we're from last time I checked, maybe the numbers are a bit different today. Last time I checked, from the 26,000 Haskell projects on GitHub, we have been in the top 10 projects, place 8 or 9 or so. So this is pretty substantial. And from the 1 million Java projects, we have been in the top 3 per mil. Top 3, order 3 per mil, also ordered 03%. So that is also pretty high. So it's always difficult to say with every open source project how much it's used. because every now and then, sometimes you think, oh, it's pretty silent, and then somebody comes along and says, I have implemented a ray tracer in Frege, and then it's, what? I have implemented, Android binding in Frege. And what? Never heard of this? And then it comes along. So that's the story of open source. Tool support, we have all kinds of plugins and so on, and integration into dependency management and build automation. And then this is training material, as I said, and then we can go into the Q&A. I guess I overextended a little. How does Frege interact with JDBC to access databases? There is on GitHub, and also from the Frege homepage, you'll find a link to a project. It's called Scirocco, like the wind, like the warm desert wind, Scirocco, and that is a language binding to JDBC. They're like two projects. One's called Chinook, which is also kind of wind, and then there's Scirocco. One of those is about databases. And that's Jim. That point. Yep. Hello, Leo.
Hello. Well, first, thanks for this presentation. It was really, really great. I had stumbled across Frege because I'm learning Haskell at the moment and professionally work on the JVM. So it was sort of natural. And I had a look at Frege before this presentation and was a bit worried there are not much changes in the GitHub repository in the last couple of years. So that's why I thought, is this going on, or is it worth it to invest in it or not? So my question is it, yeah, what's happening with Frege?
Yeah, so the main work is currently not on the language, because that's the language itself, the repository of the language itself is actually pretty stable, even though there's a little bit of housekeeping, but no major development in the language and the standard library, because that's pretty much done. Currently, the most work is in the surroundings. We currently have a master student who has just finished his master thesis and provided the VS Code plugin and the Frege language server that follows the language server protocol, such that you have then it's very easy to make the VS Code plugin. And now we have the, so it's kind of, this is the first year after the announcement of IntelliJ Fleet. It's called FLEET. And this is kind of a smallish editor, not quite IDE version of IntelliJ IDEA, which then allows including a language server protocol service. And meaning we can reuse our server there. So over the last year, the main advancement was in the tooling and surrounding. So that's the point. And it's actually mostly it's in the environment where things go on. We're kind of concerned with keeping things stable for the language, and even for small stuff where we say, well, that's kind of a housekeeping thing, and streamlining some of the APIs and in the standard library and so on, and making some small additions to make it easier to use for the purposes that we have, for example, in university. We're keeping this on a branch and using our own version, but not messing up with the public version. We want to keep it stable. That is the main thing. But we always like to have new contributors. So if you're eager to chime in, and actually that's how I started. I used the language. I fixed some typos in the comments, and then sooner than later you become a committer, and then then
Yes, then you are
then
in
all the
it.
3 weekends are gone.
Yes, that's very true. Yes.
Yeah,
So,
but
so you would
it's so much
definitely
fun.
say it can be used for production code because it compiles to Java source code, which can be just be part of the project, stay as part of the project.
Yeah, yeah. It is in use, right? So even me myself, I'm running production code with Frege, and that's also one of the really important considerations is stability of the language. You don't want to have like language version changes and then the need to update everything, and yeah, that's kind of a pain.
Yeah.
You have to do this, as happened with Python 3 and what was it, Scala 5 or whatever there was, and so on. So that we want to keep it as stable as possible.
Cool, thank you.
That's good. At the very least, for learning the new way of thinking about solutions that you have in Haskell and applying this on the Java platform, there Frege is exactly what you want to have, because it's this new way of thinking is what makes it so interesting. Yeah. And there were questions in the chat. So then was, how does performance compare with native Haskell applications? So depends on what you think is native Haskell. I assume you're thinking about the respective C backends from GHC, right? The Glasgow Haskell compiler. The Glasgow Haskell compiler, but there's many other compilers, Haskell compilers, that are not quite as sophisticated and performant as GHC. But that's the Gorilla, which does all kinds of crazy optimizations at compile time. So it's out of time compilation, and then you have like a machine code that you run. Therefore, you mean possibly native, and then you run it. This has different performance characteristics than Java, pretty much like code that you have written in C, and then you compare it to Java. Because the performance characteristics of Java, where you have very little ahead of time compilation, actually the new compilers do a little of this, but you have little ahead of time compilation, but lots of just-in-time compilation and hotspot. So typical for Java applications performance-wise is that you have a bit of a hit at starting time, like class loading and so on, before it's warmed up. And for a warmed up application, then you get the performance gains from just-in-time compilation. And this is what you also see for Frege code. And of course, Java has late binding. So if you're running on the Java platform, that's it. Yeah. With all the benefits and drawbacks that this gives. So it's actually difficult to make very good performance comparisons. Of course, we did. Another master student who implemented the software transactional memory for Frege ran extensive and very well organized performance characteristics. And they have been interesting to look at for the numbers, and even for like IO heavy applications, and then for computation heavy applications. So you find that at some point, I would put it this way: for any normal kind of application, the user of your application will not find a difference in performance whether you have written it in Frege or Haskell or Java. For any normal application, that's kind of my take, right? If you do like micro benchmarking and finding out for certain kind of characteristics like Mandelbrot sets and so on, and then you want to calculate it and you do it like crazy and solving all Sudokus and all those kind of computation heavy tasks, we have found that Frege is not optimized Frege is sometimes 10 times slower. And at times it has been 2 times faster than hand-optimized Java code and faster than hand-optimized Haskell code, GHC Haskell. So so it depends on what you're doing, right? It's in the ballpark, you're always in the same ballpark, right? For a normal application, the user will not find a difference. That were the data points, right? Would Java exceptions be considered impure? Yes. If you have an exception, so there's it's 2 ways of dealing with exceptions. One, and actually in Haskell itself, also in GHC Haskell, it's like 2 ways of dealing with exceptions. One is using exceptions as a non-local jumping point. So you're leaving your functions to a non-local caller, which is exactly, it's how they call it, isomorphic to multi-threading. Interestingly, it's isomorphic to impurity. It's another way of impurity. So the idea is that they can do this in the native declarations. At the point where, let's say, Java code would typically raise an exception, you're not using the exception mechanism, but you're returning a new type, the so-called sum type. Some people call it a union type, where you return it's either the correct value or the following exception or the following error indication. So that's the way of dealing with this. Can be an either type and one of those. That's the proper way of modeling it. If it can be in any way dealt with. There are exceptions and throwables on the Java platform that you really cannot deal with. You can only put it up the stack, the thread stack, like out of memory exceptions. I mean, what do you do with an out of memory exception? Yeah, and there's many of those that you cannot really deal with. The exception story in Java on the Java platform is kind of unsatisfying from an academic point of view. From a practical point of view, it's not so much of an issue, but it's highly irregular and kind of difficult to deal with. So the story is a little better than in Java, but we cannot totally shield from the characteristics of the Java platform when it comes to like out of memory exceptions. And yes, that exceptions are impure. It's kind of different on how you demarcate the impurity in your types. Okay. Instead of loop iteration, Haskell languages do recursion, but with recursion, you can overflow the stack. How do you avoid stack overflow? Thank you very much. So the idea is very often in these languages that you're writing code that the code reads as if it has a recursion in it. That's the way that you formulate the code. Whereas when the code runs, it doesn't really run on the stack. It runs in a while loop, for example. Here's an interesting point. And we also do this kind of optimizations. Think about an implementation of even and odd for natural numbers. So even of 0 is true. And odd of any number is not even of the number below. So odd of n is even of sorry, no, I did it wrong. The smaller number is even than your odd. So that's the right way of saying it. So it's kind of even a mutual recursion, right? But when you can write it like so, it's actually written in the standard library like that. And but when the code compiles, the compiler makes it into a while loop, even for mutual recursion. That is the point. On the other hand, since we are working on expressions only and not on statements, we actually need more stack than in usual Java applications. So it's not uncommon, it's actually pretty common for a Frege application when you run it, that you are setting the standard values for the stack size and the heap size differently. We use very little heap, but quite a lot of stack. So you're setting the sizes when starting the JVM a bit differently. Marty, I learned a lot about system out check error from this. I didn't know this existed. Okay, very good. Good you looked into this. Thing of GST native example biases. Sure, yeah, it's nice. Can you use GraalVM with Frege compile ahead of time? I haven't done this yet, so I cannot speak from experience, but I cannot see why it shouldn't work. Since you can do it with normal Java code, you can compile to the usual Java files and then use the GraalVM with it. I'm not quite sure whether it actually will. I was just thinking about, because Graal has also this triple runtime system, which is used for kind of alternative languages and run on the JVM. There, I see no benefit of doing this with Frege, because you're running Java code and not with Frege code actually on the shuffle then. But Graal should actually work. I would expect it to. What would be nice if you give it a try and let me know. Could you share a slide somewhere, please? Yes, of course, I'll do. I'll send it to Bruce, right? And then you put it somewhere. Or I'm not quite sure what the best way is.
Yes, you can send those to me, and then we'll eventually get those posted on our website. It'll take a while though, so if you have a blog or something somewhere, it would be nice if you could post your slides there, and I can just send out a link to where you have your slides posted.
I will do. Yeah, I have a personal web space. I'll put it there. Very good. And then these you can use Ant, Maven, Gradle to build projects. This Frege use those, have built system of its own. So Frege is using any of these build tools, and especially not only build tools, but dependency management systems, and including all the Maven dependencies and so on. You can use it with Gradle. There's a Gradle plugin. With Maven, there's a Maven plugin. If you want to use it with Ant, that's also possible. There's even, because some people use it in combination with Clojure and Scala. There's even a Leinigen, which it's a build tool that Clojure uses. So there's Leinigen, I guess they call it plugin, and Scala build tool SPT plugin for Frege. You'll find this on the homepage. It's linked from the homepage. Is there anything comparative to Haskell stack in Frege? I'm not quite sure. So stack, if I'm not mistaken, is in one way it's a build system, but it's also some kind of distribution, right? And Cabal, and then here we come to an interesting point where it's kind of interesting when you have kind of a third language on the JVM, or kind of a hosted language on the JVM, because I think my point is Frege is designed as a language for the Java programmer. It's not a language for the Haskell programmer. You know, it's a language for Java programmers who live in the trenches, do Java code day in, day out, and they want to learn Haskell-ish solutions and solution approaches and use it on the JVM. Cabal and Stack, they're using this kind of the package system, so that what is Maven and Sonatype and all these dependency management hostess and so on, JFrog, I guess Artifactory and what have you. This is what we use on the Java platform. Therefore, Frege just uses exactly what is on the Java platform. Right? Frege itself, the language, has no dependencies whatsoever. But of course, other projects then have dependency on Frege. And therefore, we are using that kind of ecosystem. Meaning, dependency resolution, which is part of Cabal and Stack and Haskell and so on, dependency resolution is like in Java, but for the build system, we make no, what I mostly use is the Gradle plugin because I do most of my builds in Gradle. I know some people say Maven is better than Gradle, and then you have the other way around. I settled mostly for Gradle at this point. And I'm using the plugin that is provided there. I also provided a plugin myself. But the newer ones from my master student is much better. So you start your Gradle plugin. I can actually show this. There we go. Let me quickly check. We do have here you see the build Gradle. There's a plugin for the Frege. That's the Frege Gradle plugin. And you say what version you want to use, what's your main module to start, and if you're starting read eval print loop directly through the build, meaning you have everything when you're starting the REPL, then the whole class path is correctly set, that the REPL has everything available to play with. That's also pretty nice. That's what you can use here. So that's like these lines is everything that you need to know for running your Frege code, compiling and so on. Have a Maven local, have a dependency. This is only if you were using Frege FX. Well, then you need an. Here I'm using a snapshot because I made a small change and built locally. Otherwise, that's it. And here below, there's an old version of my plugin where I didn't depend on that over here. That's only there for backwards compatibility for old projects. But that's the thing. To do that is reasonably easy, I would say. Has there been any thought adding dependent types to Frege, like what is available in Idris or Acta? Dependent types is so nice. It is so nice. Well, first there's dependent types as a language extension to Haskell, meanwhile, if I'm not mistaken. It's one of the newer language extensions that you get, like language pragmas that you're using. Brings me to a second point. We are not supporting the 1000 language pragmas that GHC Haskell is using, but we have like around 12 or so that we looked at that we want to have, bang patterns and dot notation and one of those strings and things that you really need. And those are baked into the language, and we're not dealing with this kind of language extension thing that GHC Haskell is using. Dependent types would be an interesting extension. What I'm currently doing, if I want to play with dependent types, let me quickly think. Maybe that's linear types what I'm thinking of. Oh, maybe, no, dependent types, right? So dependent types, what I'm using is actually Idris, because Idris has a backend where you can compile to the JVM. Actually, it is written by Marimuto Matasai, who has also been massively contributed to Frege. So it's an old friend. And that works well. Also, interest is pretty cool. You can even compile it to JavaScript. And because I always had some problems with the interest backends, and therefore I usually compile it to JavaScript. But of course, dependent types and linear types both is very interesting. Another, making it even more, what you can express in your types becomes more and more and more. It's, in any case, it's a good step if you want to go in this direction to first get your Frege Haskell under your belt before you, and then going into dependent types is the next step. That's at least that it was for me. In Haskell, even basic things are in libraries. And Frege uses these. Yeah. In Frege has its own libraries, right? Mostly Java libraries, and like JavaFX, for example, right? JavaFX is the library, and then we provide in the native declarations for this. And we do not consume any Haskell, from the Hackage libraries. There has also been an attempt to have a language on the JVM that integrates these kinds of that kind of approach. That is, Rahul has done this in for the ETA programming language, ETA, which to my best knowledge is discontinued like 2 or 3 years. But there's something that you can look at. The point is, in practice, right, working on the JVM speaks against using the Hackage packages, because they are built for a different purpose. There are some that are, of course, general purpose, and the standard library that comes with Frege is inspired many times kind of copied and adapted from what is available on Hackage, because most of the Haskell code is just drop-in replacement in Frege code. You can just put it in, as long as there are no exotic and crazy language extensions in the Haskell code. So then, but all the normal code can just be used as is. Therefore, it's pretty easy to make your own library for that. Talking about FregeFX, it's actually FregeFX, so the JavaFX language binding for Frege. This is kind of interesting, Frege, JavaFX is a really broad interface. It's a very broad API. It has about 800 classes, and if I'm not mistaken, 40,000 methods. And then providing the native declarations for all of those has been a bit of a challenge. But I actually did this. Don't ask me what I do on weekends. So does Frege standard library avoid problems like partial functions in the prelude? I'm thinking of things like taking the head of an empty list. Yeah, that is kind of there's a safe head. And there has been differences. I didn't follow the latest development there on the Haskell side. If I'm not mistaken, I can actually look this up. If I'm not mistaken, there might still be. Let me quickly check. Let's go to the playground. Because if we go, let's go here. If we, I guess the head function, head of an empty list. This might actually print in head of an empty list. Let me quickly check whether this even compiles. Because there, this is going to be IO unit. This needs to be so. I need to run things fancy Haskell. Yep. Go there. Put an empty list. Yeah. So list view. Yep. That is true. I cannot actually do this in this context. And that is over here. Oh, so there's not necessarily a show for this. Okay. Yep. Let me quickly check. Show this. Yeah, only works if you have a list of entries with this. If I want to print it, printing only works if you have a list of types that have a show instance, that have a toString, so to speak. And an empty list doesn't have this, because therefore I cannot print it. But I could try to evaluate this anyway. I could try to evaluate it respectively. And we can try it in the console. And it might be even nicer to put it in the console, because here we can. The prelude is included. Head of an empty list is of type A, so that's what it's saying. And but it doesn't give you a value, so it shields you from. I'm not quite sure how the implementation works. This is only this is because this runs now in the REPL. The execution context of the REPL is it tries to give you the best possible information, either running the function instance, or if it cannot run it, it gives you the type. So that's kind of a side effect now of the REPL. But I can look it up. So mostly we try to use only total functions. There is a way of demarcating partial functions. There is in partial type class that you can use, but more for I'd say historic reasons. There might be two different versions of the head, and maybe even two different preludes that you can use with a head and a safe head. That is, there's so many books that teach Haskell that are using lists to work with, and then using head and tail and init and so on. And in order to be compliant there, we have at least the possibility to use it. That is I'm not quite sure what the best solution would be. I always like the regularity, and I can very well remember the kind of disappointment that I felt myself when reading about Haskell and being so excited about all the safety and robustness characteristics, and then running into calling head on an empty list. So that is, of course, better to do with dependent types. So
Okay, so are there any other questions here? I think I kind of dragged you along there on some of those those questions. You know, I ran into that same problem that you did when I was learning Haskell, and I was real excited. And then I'm like, wait a minute, what are all these partial functions doing in the prelude?
Yeah, that's totally true.
And then
And
I started realizing, wait a minute, why do we have like 6 different types of strings? Right? Because you've got text, and then you've got, you know, lists of bytes and all these other things. And it's like, wait a minute. And then they tell you, don't do what the textbooks say, where a string is a list of characters, because it's not performant. You're supposed to use text. Never mind what you got taught in all the textbooks on Haskell. So it kind of surprises me.
Yeah, so this is different in Frege, head of whatever thing that probably doesn't even work. So okay, it does automatically the unpacking. So this now looks as if this string would actually work in the same way as a list of characters, like in standard Haskell, but it's behind the scenes. It's a normal Java string. So the type of whatever is a string.
It's string, not text, and not a list of characters.
Yeah, it's not a list. It's not a list of characters. You can put it in. You can convert between listing characters and a string with packed and unpacked. So you can very easily unpack and then work with all the map, filter, reduce textbook examples. That's one of the changes that I meant when I say there's obvious things to change between the Haskell textbooks and using Frege for this specific reason. You know? The Java string type is really good to use on the Java platform. It would not make no sense to use a list of characters for this.
Right, because a Java string is immutable anyway, and that's a desirable characteristic that you would want.
Yeah.
Okay. So I'm not seeing any other questions here in the chat. Oh, wait a minute. We had David was saying my list. What was this?
Yeah, you have to give it what kind of list it is. Yeah. True.
Okay, yeah, you're putting in an explicit type for it.
Yeah. And then when you run it in the REPL, then you see what we have over here. It gives you back the type. It actually doesn't run it. That's the characteristic of the REPL at this point. I got Frege runtime undefined. Yeah. Head of for that list of empty list. Yeah. That is when you don't have it in the REPL. That's when you run the code. But could you try it? That's awesome.
All right. So we have some people actually trying it out. That's great. So any other questions? I'm not seeing anything. All right. So if not, we usually have a big round of applause here for our presenter. And I know it's getting awfully late here for you. So I'm seeing some thumbs up here. So thank you.
Thank you very much for your patience. I'm sorry for taking longer than expected. But once you get started on this, and then
yeah, it's your favorite topic. You love to talk about it. It's obvious, even if it means it's some ridiculous hour of the morning for you, or maybe the sun is actually coming up in Switzerland.
Yeah,
all right,
almost.
So I think we're about ready here to do the raffle. So what I'm going to do here is I'll stop the recording at this point.